Okay. So yesterday we were talking about membership algorithm, and I had told you that membership algorithm is decidable for many languages, right? Okay. Now let us see membership for CFL. Let us see membership for CFL. Okay. Let us see membership for CFL. So this is the QR code of my compiler design textbook. This book will be helpful for BTech, MTech and GATE. You can buy this from PW store. And this is the QR code of my Telegram channel. Please join this. This is the QR code of my Telegram channel. Please join this. Okay. Okay. So today we are going to see membership for. So yesterday also we have seen membership. In today's class also we are seeing membership. Yesterday also we have seen membership. And today also we'll see membership. Okay. So what are the various membership algorithms for context-free languages? Membership algorithms, for context-free languages, right? We have already seen one membership algorithm, if you remember. Hi Mohit, how are you? Mohit, which college are you from? Everyone has a YouTube channel. All the names, motivation, all time for life. All the names are like something. Everyone has a YouTube channel. Okay. Membership for CFL. Now, the first one is brute force. We are not going to use brute force because it is exponential time. The first one is brute force. This is exponential time. This is exponential time algorithm, right? And the second one, do you remember the membership algorithm that we discussed for context-free languages? I have created by watching your TOC lecture, sir. Your lecture is awesome, sir. Very good. What are you doing on what are you posting on the YouTube channel? Right. So what I am saying is, we have already seen one membership algorithm for context-free languages, right? Do you remember what that algorithm was? We have seen it long back, long back. So do you remember it? Membership algorithm for CYK. Membership algorithm for CYK. We have seen very long back. Do you remember it? Just watch your lecture, get more energy and post some thoughts as like shorts, sir. Very good. Okay, fine. So one algorithm that we have seen is 𝐂𝐸𝐾, if you remember it. Do you remember the time complexity of 𝐂𝐸𝐾? Do you remember the time complexity of 𝐂𝐸𝐾? We have seen 𝐂𝐸𝐾 long back, few months back. So I don't know if you remember it. Okay. But we have seen 𝐂𝐸𝐾. Just revise those videos once where 𝐂𝐸𝐾 is present. Very good, Prashant. So the time complexity is order of n cube, right? And there are other membership algorithms like LLK and LRK, which are used in compiler design. LLK and LRK are used in compiler design because they take less complexity, order of n. But the problem is LLK and LRK will not be able to parse all the grammars. Okay, but they run faster, and so we use them in compiler design, right? Because we don't need all the grammars for programming languages. Only some class of grammars are sufficient for all programming languages, and they can be parsed by LLK and LRK. That is why we are going to use LLK and LRK. So brute force we are not going to study. There is nothing to study. You have to generate every possible string and check if it is equal to the given string, right? So brute force we are not going to study. And 𝐶𝐸𝐾 we have already completed. Now let us look at LLK and LRK, which takes order of n time. LLK and LRK, which takes order of n time. Which takes order of n time. Which takes order of n time, right? Now let's look at LLK and LRK. Properties of 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 LLK and LRK. Right? So LLK and LRK, LLK and LRK grammars, LLK and LRK grammars are unambiguous. LLK and LRK grammars are unambiguous, right? Therefore, they are suitable for compiler design. Therefore, suitable for compiler design. Suitable for compiler design. Some unambiguous grammars. Some unambiguous grammars are neither LLK nor LRK. Some unambiguous grammars are neither LLK nor LRK. If a grammar is ambiguous, then surely it is not LLK or LRK. If a grammar is ambiguous, then surely it is not LLK or LRK. If a grammar is ambiguous, then surely it is not LLK or LRK. Right? So, if you have context-free languages, then a proper subset is deterministic context-free languages. Right? Now, these deterministic context-free languages can be parsed by LR1. In a time order of n. Now, all the context-free languages can be parsed by 𝐂𝐤𝐽𝐾. All the context-free languages can be parsed by 𝐂𝐤𝐽𝐾 in order of n cube time. Now, this deterministic context-free languages are sufficient for describing all the features of a programming language. For determining all the features of a programming language. Oh, Kurukshetra University, is it? Okay. So, the deterministic context-free languages is suitable for all programming languages. All the features of programming languages fall under deterministic context-free languages. Therefore, for compilers, DCFLs are sufficient, and for every DCFL there is a LR1 parser. Right? Now, when you are simplifying the grammar, when simplifying a grammar, first step is we delete epsilon productions. And second step is delete unit productions. And the third step is delete useless symbols. Delete epsilon productions, delete useless productions, unit productions, then delete useless. So why do you think that we have to follow this order? You have to follow this order, right? Can you tell me why this order is followed? Can you tell me why this order is followed? Can you tell me why this order is followed? Can you tell me why this order is followed? Nahi yaad hai. So when you delete the epsilon productions, you will get unit productions. That is why first delete the epsilon productions, then unit productions. Now after deleting unit productions, you will get useless productions. So that is why we are following this order. Right? Now what is LLK and what is LRK? So LLK is a top-down parser. You will learn about it in compiler design. LLK is a top-down parser You will learn about it in compiler design. And LRK is a bottom-up parser. You will learn about it in compiler design. And first L means left to right. First L means left to right. Second L means leftmost derivation. Second L means leftmost derivation. And this K means look-aheads. K number of look-aheads. So while taking a decision, how many symbols are we seeing? Right? Now LRK is bottom-up parser. LRK is bottom-up parser. And L means left to right scanning. L means left to right scanning the string. And R means reverse of RMD. And R means reverse of RMD. And K means look aheads. K means look aheads. And K means look aheads. K means look aheads. K means look aheads. K means look aheads, right? Now let us see LLK. Now let us see LLK. A grammar capital G is LLK. A grammar capital G is LLK when K symbols of input are presented to the compiler when K symbols of input are presented to the compiler at a time, presented to the compiler at a time, presented to the compiler presented to the compiler at a time, the production that is used in every step of derivation in every step of derivation is uniquely determined. The production that is used in every step of derivation is uniquely determined, right? In every step of derivation, in every step of derivation, we use one and only one production. We use one and only one production. One and only one production. So LLK is order of n time. So LLK is order of n time. So LLK is order of n time, right? Now let's look at LRK. LRK. Let's look at LRK. Nobody with somebody. No one has real names. Everyone is having a YouTube channel. Nobody with somebody. Hello, hi. Hi. Okay. A grammar is LRK if when K symbols if when K symbols of input are presented if one K symbols of input are presented if one K symbols of input are presented if when K symbols of input are presented to compiler to compiler to compiler to compiler K symbols are presented to the compiler at a time comma the production that is to be used the production that is to be used in every step of derivation is uniquely determined right? It takes order of n time. It takes order of n time. Right? So the membership algorithm in context-free languages is decidable. The membership algorithm, no sir, actually you should be showing username from this month, not as real name. Right. So 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 see, for every context free language, there is a context free grammar, and not every but almost every context free grammar can be converted to CNF. But if you have epsilon productions, you cannot convert. That is an exception, but almost all the context free languages can be converted to CNF. And now once you have CNF, you can apply CYK, right? So this step is decidable, this step is decidable, and we have a algorithm here. There is algorithm, therefore membership is decidable, right? So membership in context free language is decidable. So membership at context free languages is decidable. Membership of context free languages is decidable. Membership of context free languages is decidable, right? Right? Now, for all deterministic context free language, there exists L or K. For all deterministic context free language, there exists L or K. For all DCFL, there exists L or K. There exists L or K. And for all L or K, there exists DCFL. For all L or K, there exists DCFL. For all L or K, there exists DCFL, right? Hello to Finn. Yeah, there are no other slots on YouTube channel. So we have only this slot. Okay. Now, for all LLK, for all LLK, there exists DCFL. For all LLK, there exists DCFL. For all LLK, there exists DCFL. But for all DCFL, there need not be LLK. There need not be LLK. There need not be, for all DCFL, there need not be LLK. There need not be LLK, right? So what do I mean by that? If this is DCFL and if this is CFL, For CFL, there is 𝐂𝐲𝐬𝐞, and for DCFL, there is LRK. For DCFL, there is LRK, but for some of the DCFLs, there is LLK. For some of the DCFLs, there is LLK. For some of the DCFLs, there is LLK. Right? Right? So what does that mean? There are some DCFLs. There are some DCFLs. There are some DCFLs which are not LL1, which are not LLK. There are some DCFLs which are not LLK. So LLK is less powerful than LRK, right? Now, in LLK and LRK, in LLK and LRK, every string in LLK and LRK, every string will have exactly one derivation tree. Every string will have exactly one derivation tree because the grammar is unambiguous, right? Exactly one derivation tree because the grammar is ambiguous. Because DCFLs are unambiguous. DCFLs are unambiguous. So day before yesterday class, I told you that regular and DCFLs are unambiguous, and ambiguity starts beyond DCFL, and ambiguity starts beyond DCFL, right? Right? And LLK and LRK can parse in order of n time. Can parse in order of n time. Every feature of any programming language, every feature of any programming language, every feature of any programming language is DCFL, So compilers don't need 𝐂𝐲𝐬𝐞. So compilers don't need 𝐂𝐲𝐬𝐞. Every DCFL has a corresponding, every DCFL has a corresponding LRK. Every DCFL has a corresponding LRK, right? So if you see DCFL, it has a corresponding LRK. Every DCFL will have a corresponding LRK. Every DCFL will have a corresponding LRK. Every LLK is DCFL. Every LLK is DCFL. So which means if I write like this, LLK, DCFL, it is not all DCFL but only some of them. Every LLK has DCFL. Every DCFL is not LLK. Every DCFL is not LLK. Every DCFL is not LLK. If a grammar is LLK, if a grammar is LLK, we can surely call it. If a grammar is LLK, we can surely call it as LLK plus 1. If a grammar is LLK, we can surely call it as LLK plus 1, which means if it is LL1, you can call it as LL2. If it is LL2, you can call it as LL3, and so on, right? And if a grammar is LRK, if a grammar is LRK, we can surely call it as LRK plus 1. We can surely call it as LRK plus 1, which means if it is LR1, you can call it as LR2. If it is LR2, you can call it as LR3, so on. Okay, fine. We will end the session here. Tomorrow we will continue. Okay, tomorrow we will continue. I am not feeling well today, so tomorrow we will continue. We will end the session here.